This is the lesson for Handout C. So you'll see that the questions on Handout C are numbered 25 through 31 on the first side, and then 32 through 39 on the second side. So this is the similar problems to the first side, and so what I've done here is I've numbered some problems and come up with problems very similar to what you'll see on that handout, just different numbers. So taking a look at the first problem, it's finding the point at which the two lines cross, solving this system. And so whenever you've got y by itself, use the substitution method. And so in this case, I'm going to go ahead and take this expression right here, this x plus 3, and I'm going to put it in place of y in the equation below. So I'm going to rewrite that equation, 2x plus y, but in place of y, I'm going to write x plus 3, and this is all going to equal 6. So from this point, I'll go ahead and collect some like terms. These two terms right here combine together to make 3x. And then I'm going to subtract the 3 from both sides, and so I have 3x equals 3. So you'll see when I divide by 3, I end up with x at 1. So I go ahead and take that 1, substitute it back into that top equation. So I've got now y equals, but in place of x, I'm going to write 1 plus 3. And that makes 4. So there's my y value when x is 1. So 1 comma 4. That is the point where the two lines end up crossing. So for the next problem, number 26, you're going to end up wanting to use a different method. The elimination method works really well. So I could multiply the bottom equation by 2 as long as I multiply each of the terms. That's the key, each. A lot of people forget to multiply this negative 12 by 2. See, if I do that, then this will become a negative 2x, positive 6y, and a negative 24. So let's go ahead and write that down. So I'll start with rewriting the top equation. 2x plus y equals 3. And then I'll rewrite the bottom equation in the new modified form. Negative 2x plus 6y equals negative 24. And so when I go ahead and add those equations together, I end up canceling out the y or the x terms. Leaves me at the 7y equals 21. I had to subtract because they're opposite in sign. That's another mistake people will make, is just not looking carefully at those signs. And it makes a negative 21. If I wasn't careful, I would have made an error myself there. So divide by 7, y equals negative 3. So I go ahead and take that negative 3. Now let's substitute it. Probably put it into this equation right here. 2x minus 3 equals 3. So when I add the 3 to both sides, I end up with a 2x equals 6. So from that point, I just need to divide by 2, and I've got my answer. X is 3. So there it is, 3 comma negative 3. That's where the two lines end up crossing. So question number 27 is asking us to graph this system of inequalities. And so looking at the first inequality, I would use the slope-intercept form. There's my y-intercept, positive 4. So I'm going up 4 spaces, 1, 2, 3, 4. Put the dot there. And then use the slope, 2 to 1. So I'm going up 2 spaces over 1 to the right. Ran out of room that way, so let's go the other way. Down 2, 1 to the left. Gets me on that same line as well. And so once I've got some points, I can go ahead and draw the line. Now careful on the line type, it's a dashed line because there's no line underneath the inequality sign. So points on the line do not represent solutions. Y values are greater. Greater means bigger. Bigger y's are above that line. So let's just put some arrows in the direction we would shade. Let's take a look at the next one. This one I would go ahead and solve for y, because if I divide by 6 for the x-intercept, I end up with a fraction. It might be a little bit tough to graph that. So I'm going to move some terms around. Move this 6x over. So now I've got 2y greater than or equal to negative 6x minus 2. So you see when I move a term to the other side, it just switches signs. Now divide by 2. I've got y is now greater than or equal to negative 3x minus 1. Where did I get the negative 3? Well, I divided. Negative 6 divided by 2. Negative 2 divided by 2 makes the negative 1. So I can go ahead and graph that point. Negative 1, and then use the slope. Slope is down 3 over 1 to the right. Or I could go up 3 spaces, 1, 2, 3, 1 to the left. And that gets me on that same line. So I go ahead and draw the line. It's a solid line. Solid line because there's a line underneath. And the values of y need to be greater than. Greater than means above. So I end up shading in this area here. Well, 28 and 29 are problems in which we are applying these ideas of systems of equations. We're going to set up an equation to match this problem here. A jar of dimes and quarters contains $15.25. There's 103 coins in all. And so how many of each are there? So dimes, we don't know the number of dimes, so we're going to set up a quantity equation. D plus Q, don't know the number of quarters, but we know there's 103 altogether. And the value, so the value equation is 10D, 10 times the number of dimes, 10 cents times the number of dimes, plus the value of a quarter, 25 cents times the number of quarters equals $15.25. Now this is in dollars and cents. I want to write it in dollars, or in cents, because I have cents over here for the values of the dimes and quarters. So 1,525 cents. So I need to find the value of each coin. So let's go ahead and multiply by -10. Each number there by -10 makes -10D minus 10Q equals -1,030. And so when I add this stuff together, I end up with a 15Q equals, do the subtraction here, borrow a little bit, and I get 495. And so when I do the division, 15 goes into 49. Seems like a tough problem, but start with just 49. It goes in there 3 times. And so we have 4 left over. So we get to put a little 4 right there. So 45, it goes in there 3 more times. So 33. So to find out the number of dimes, just substitute 33 in for Q. So D plus 33 equals 103. And so you're just subtracting 33 from both sides. Gives you the number of dimes. So dimes is 70. 70 dimes, 33 quarters. Well, the next one, we're dealing with a ticket problem, admissions, but it's set up the same way. So there's 429 people at a play. There's adults and children. Adults cost $1, children 75 cents. The receipt was $372.50. How many adults and children attended? Well, we don't know the number of adults, don't know the number of children, but we do know there are 429 of them if we add them all up. Well, the cost of an adult ticket was $1. The cost of a children's ticket was 75 cents. Now I'm going to use 0.75 because I've got such big numbers here, I don't want to have to change it to all the cents. So $372.50. So what I'm going to do is I'm going to multiply that bottom equation by -1. So when I do that, all the signs are going to end up switching. So let's go ahead and rewrite our equations. We've got the A plus C equals 429. Over here we've got -1A minus, oops, this should have been a plus right here. Initially it was a positive. We were adding 75 cents times the number of children to $1 times the number of adults to equal that amount. So now it's minus 0.75C equals -372.5. So when I do this subtraction, you got to add a decimal and you've got to borrow. So I'm going to add these numbers up, but I have to subtract here because they're opposite in sign. So I got to borrow from the 9, change it to an 8, and this becomes a 5 point. This is a 6. Now I've got to borrow from the 4, change it to a 3. 12 minus 7 makes 5. So 56.5 equals 0.25C. So what we do is just do a division problem. So let's set it up. 25 into 5,650. How do I get that? Well, I moved the decimal over 2 spaces here, so I got to do the same thing over here. And so when I do this, 25 into 56, we know goes 2 times. It makes 50. Do the subtraction, got 65, so another 2 times. Makes 50 once more. Do the subtraction, we got 150. Goes into 150 6 times. So there it is. C equals 226 children. So that's how many children ended up attending. Well, how many adults came? Well, if we subtract this from the total, it'll give us our answer. So let's do that. 429 minus 226. So when I do that subtraction, I end up with 203 adults ended up showing up. So let's take a look at question 30 is a multiplying 2 binomials. Use that FOIL method. First, outer, inner, and last terms when we do this. So my first terms are this. X times x makes x squared. And then the outside terms, x times by -4. So plus x times by -4 makes a -4x. And then move on to the inside. 3 times x. So 3 times x makes a 3x. And then the last terms, 3 times negative 4. So 3 times by negative 4 makes negative 12. So I collect some like terms. These two terms right here combine together as 1. So I've got x squared, and this makes a negative x and a minus 12. And that would be the answer. Last problem here is one in which we need to reduce a fraction. So look for common factors. Divide, take out the common factor of 2. Divide each of the coefficients here by 2. We end up with a 4 and a 1. So let's go ahead and rewrite those. 1 over 4. Now leave some room for some x's. So it looks like we've got 9 x's on top, 12 on the bottom. So these 9 x's will cancel out. They'll be all gone because I'm going to take them all away. And I'm going to take 9 from the bottom, and that leaves me with 3 x's on the bottom. So there's my answer, 1 over 4x to the third. Well, those are problems on the front side of Handout C. Check out part 2 for the problems on the back side.